Good morning, students. So in the last class we discussed the shift registers, right? Actually we discussed the register, and what is a register? Register is a combination of flip-flops, and whenever we are going to hold a multiple number of bits, we are going to use multiple number of flip-flops, right? So this combination or a multiple number of flip-flops together is called a register, and we have seen two different types of registers. One is based on the direction of data to be shifted, and uh, second one of the data is going to be loaded in these registers. Okay, so based on these two categories we have seen the first one, that is left shift operation, right? So first we have loaded the data in these registers, and that data will be shifted towards left, right? Sorry, right, we have seen actually. So in today's class we will see uh, how to shift that data towards left, right? So we have used D flip-flops for left shifting, sorry, right shifting. We will use the same flip-flop for left shifting now, because D flip-flop is very easy to understand compared to the other three flip-flops, right? So next, uh, today's topic is left shift operation. Left shift operation. So again we are going to use a 4D flip-flops, but in this case we are going to input the data from right. Same 4D flip-flops, you can connect them in cascade, right, in series. And in case of right shift operation, we have supplied the data from left, right? But now we are going to perform a left shift operation. The data has to be supplied from the right. Okay. So this is the first D flip-flop. I'll denote its input as D1, and output of that particular flip-flop is Q1. Second input is D2, output is Q2, D3, Q3, D4, and Q4, right? So here I will write the data as a serial in, okay, and the output I will write it as serial out, right? So, and the output of one flip-flop is connected to input of next flip-flop, right? And we are going to provide a common clock for all four flip-flops, right? So here we are seeing the left shift operation for synchronous sequential circuit, right? So this is the control input. We denote this control input as clock. Okay. So when what is the first operation? We need to load the first flip-flop, right? So either with the 0 data or 1 data, right? How do we load it? First we will make either d1 is equal to either 0 or 1, right? So if I want to load 1 into the first flip-flop, so I'll make a d1 is equal to 1. So if I make d1 is equal to 1, what happens? Here, until and unless we provide this control input, that is clock input, we cannot make that 1 to get loaded into this first flip-flop, right? So we will make d1 is equal to 1, and next we will apply the control input, right? So either we can apply a positive edge or a high level, right? So depending on that particular flip-flop, right? So we have already seen there are two types of flip-flops. One is level triggered, and second one is the edge triggered, right? So depending on that we are going to provide these control inputs, right? So let us assume, so in the last class we have assumed the edge triggered flip-flop, okay? So again we will assume the same type of flip-flop here, right? So where when the positive edge occurs on this control input, right? Let us say this is the control input, that is clock. When the rising edge occurs, when we will get the rising edge? When the clock changes from 0 to 1, right? So when it changes from 0 to 1, we will get a rising edge, and this edge is applied to the first flip-flop. And if we keep d1 is equal to 1, what happens? That particular data which is equal to 1, that will be loaded in first flip-flop. So that means the data which is loaded in first flip-flop is equal to 1, right? And rest all will be equal to 0, because initially we are assuming initially we are assuming these flip-flops are going to hold zeros, right? So the same data will be kept as it is. Uh, uh, mm, Same data will be kept as it is in the remaining flip-flops, right? Since we have made only d1 is equal to high, that means that high value or 1 is loaded into first flip-flop and other flip-flops are going to remain 0. Okay, next, when we apply, uh, let me take the same value for d1. So I'll keep d1 is equal to 1. So when we apply the second clock pulse, so here let me draw q1, q2, q3 and q4. Okay, so when initially all are 0, so when the first edge occurs, q1 will become 1 because d1 is high. q1 is high because d1 is high, right? So q1 will become 1, and q2, q3 and q4 will remain 0 until the next edge occurs. Now, so when the second clock pulse, when the second rising edge occurs, let us assume d1 is equal to 1. What happens to q1? q1 will remain in 1. q1 remains 1, and q2, what was the previous data on this q1? Is 1, right? So this 1 is applied to d2, right? So that means the 1 will get shifted to the next flip-flop, right? So q2 becomes 1. The previous 1 was shifted towards left, and the output of second flip-flop will be equal to 1. That means the second flip-flop gets loaded with the data which is equal to 1. And what about q3 and q4? They remain equal to 0, right? So next what I'll do, see here I'll make d1 is equal to 0, right? So once I make d1 is equal to 0, what happens? In the first flip-flop, 0 gets loaded, okay, and the previous flip-flop output was 1. This one is given to the second flip-flop where d2 is equal to 1. That means q2 remains in its previous state, that is 1, right? And what about q3? Since q2 is connected to d3, and what was the previous value of q2? It was 1, right? And that 1 is connected to d3 means q3 will become 1 when the third control input comes, right? So that means what is the data here? Initially it was 1000 when the first control input is applied. When the second control is applied, here I kept d1 equal to 1. So this 1 will be shifted towards left, and this 0 will shifted towards left, and this 0 will shift towards left. Okay, so what is happening here? This 1 shifts here, and whatever value you keep on d1, so that will appear on first flip-flop, right? So this is the data in these 4 flip-flops when the second control input is applied. When I apply third control input, I am making d1 is equal to 0. What happens here? First flip-flop gets loaded with 0, and this one will shift towards left, and this one will shift towards left, and this 0 will shift towards left. So what is the data after third control input? It is 0 1 1 0, right? The same thing we got here, right? 0 1 1, q4 remains in its previous state, that is 0. Again I'll keep d1 is equal to 1. You can keep anything, you can load the first flip-flop with any of the data, okay, either 0 or 1. Next what I'll do, I'll keep d1 is equal to 0. When I keep d1 is equal to 0, and if I apply the next clock pulse, that is fourth control input, what happens? q1 will remain 0. Why? Since d1 is equal to 0, right? And what was the previous value of q1? It was 0. So that 0 will be shifted towards left. That means second flip-flop gets loaded with 0. And third flip-flop gets loaded with 1. That means the third flip-flop remains in its previous state because this one shift towards left, right? Next this one shift towards left, so that is 1, and q4 will become, right? So what is the final data in these 4 flip-flops after applying 4 clock pulses here, or 4 control inputs. It is 0, 0, 1, 1. The same thing we got here, 0, 0, 1, and this one, right? So this is the left shift operation, right? So same thing you can also explain with the help of the other flip-flops, but you need to modify those flip-flops, right? So instead of taking the other flip-flops and modifying them, we will make use of the simplest flip-flop, which is called a D flip-flop, right? So I hope you understood the left shift operation. In the next slide, we will discuss how the registers are categorized based on loading of the data, right? So we are going to again discuss 4 operations: Siso, Sipo, Piso, and Pipo. That is serial in, serial out, serial in, parallel out, parallel in, serial out, and parallel in, parallel out. Okay. Moving to the next slide. So here we are going to discuss the same shift registers, but based on how the data is loaded. Based on how the data is loaded. How the data is loaded, right? So data is loaded in 4 different forms. One is serial in, based on how data is loaded and taken out, you can say, and how the data is taken out from the shift registers or registers. Serial in, serial out. That means the data is loaded. That in means the data is getting loaded into the register, and out means that data is taken out from the registers, right? So here the data is loaded serially in the registers and it is taken out serially from the register. Next, serial in, parallel out. What are the differences? You will come to know once I discuss these concepts. Okay. Third one, parallel in, parallel in, parallel in, serial out, parallel in, serial out, and fourth one, parallel in and parallel out. Okay. So here I have already discussed the first one, that is serial in, serial out. Either you can explain a left shift operation or right shift operation for the first operation, that is serial in and serial out, right? So here again we are dealing with 4 D flip flops which are connected in cascade. In all these operations we are going to make use of 4 D flip flops, and what are the differences, that you will come to know now. Okay. Same thing, either you explain left shift or right shift operation, that gives you the serial in and serial out concept. Okay. So here this is the control input, which we call it as clock, okay, and these are the inputs. The same circuit what I explained in the previous slide or the last class, right? It was the same circuit. D2, Q2, where Q1 is connected to D2, Q2 is connected to D3, Q3 is connected to D. Okay, and this out we call it as serial out, and this in we call it as serial in, right? So whatever data you load here, right? So it's like it's a single end of the pipe. Sorry, 2 ends of a pipe, right? So from one end you are putting a water, and from the other end you are receiving that water. It's water in, water out, you can take, right? So you have only one entry for that water in that pipe and one exit point at the other end, right? For that pipe. Okay. Now, so what happens here? When the water enters from this end, it will come out of that pipe from this end, because it doesn't find any of the outlets, right? So the pipe is solid, right? So it doesn't have any small holes, right? So it is not you can say it is not a leaking, right? So if that is the case, then from one end you will enter, the water will enter, and from the other end the water will be taken out, right? So in the same manner, whatever data you load in first flip flop, right? So that has to be taken out from the fourth flip-flop itself, right? So this pipe has small 4 flip-flops, you can say, right? So you don't have any exit points, right? So I have one entry point at this point and only one exit point at this point, right? So let us say now D1 is loaded with 1, that means that 1 will get loaded in this first flip-flop, right? So when the first control input is applied, this one gets loaded into the first flip-flop, right? So when the next control input is applied, you just go back and refer the previous slide or previous class videos, right? This one will shift towards right. So this is shift right operation, which we have already discussed in the last class, right? So here I am not bothering about this one, right? Here I am not bothering about this one. I am just going to apply the control input. What happens to this one initially? Only here I am talking about only one data, okay? So here initially D1 is kept 1. What happens after giving first clock pulse? That 1 will be loaded in first flip-flop, right? So when I give the second control input, that 1 will shift towards right and that will be loaded in second flip-flops. When I give the third control input, this one will shift towards right and it gets loaded into third flip-flop. And when I apply fourth clock input, that this one will get shifted towards right and it will be available at the output of fourth flip-flop. That means if you want to, if you uploaded only one bit in one of the flip-flop, right, you have to apply 4 control inputs to take out that particular data from the fourth flip-flop, right? So this operation we call it as serial in, serial out. That means serially we are inputting the data and serially we are taking out the data, right? Not at a time, right? So I cannot take because I don't have any outlets at these points. If I have any outlets of these points, that will become a parallel out, right? So but I don't have any exit points at these points, right? So I have only one entry point and only one exit point, right? So this data, if you want to take it out from this point, so this data has to reach the last flip-flop, right? So then only you can take it out from this fourth flip-flop, right? So that can be done by applying the control input, right? So now let us say next serial in data is 0. So when I apply 0, when I apply the first control input, this 0 gets loaded into first flip-flop, right? So after that, when I apply the second control input, this 0 will shift towards right, and this after applying third clock pulse, this 0 will shift towards right, and finally applying the fourth control input, this 0 will shift towards right and it will be available at the output of fourth flip-flop. Clear? This means the data gets shifted towards right and we are inputting the data serially and we are taking out the data serially, right? So this is the first operation, the first concept, that is serial in and serial out. Okay, so rest 3 we will discuss in next slide.